Continuing our discussion of different wireless and mobile technologies, let's talk about ZigBee for a few minutes. Now ZigBee, even though it has a funny name, it refers to the 802.15.4 standard that the IEEE put out, and it covers wireless technologies that are very specifically designed for automation systems, like industrial control systems, monitoring systems, and so forth. And you've probably seen these and used these every day. A lot of these systems control things like automatically shutting down power, controlling lights, controlling HVAC units, air conditioning, and so forth. There is also some implementations of ZigBee that work around the home. Remember, if you have your key fob to automatically open your doors from a distance, you may be using a form of ZigBee since it's radio. Now, ZigBee is a low-cost, low-power wireless mesh network standard. And when we say wireless mesh, what we mean is that in ZigBee you can have many devices all meshed together communicating with each other. And typically they're in ad hoc networks. There's no real management for a ZigBee network except for a few minor details. The ZigBee Alliance is the group of manufacturers that put out the ZigBee standard, and they're the folks who make sure that ZigBee devices adhere to that standard and that they ensure interoperability. Now, these ZigBee devices that you can get can be networked in what's called a wireless personal area network architecture, very similar to Bluetooth, although ZigBee has a much greater range than Bluetooth does and can use several different devices. In fact, it can contain up to 65,536 devices. Now, it uses the same DSSS signaling as 802.11a networks and earlier networks use, but it's not the same thing. In fact, ZigBee is not interoperable with Bluetooth or any of the 802.11 standards, which actually is a good thing because you really would not want interference from those networks to interfere with devices that control things like humidity controls, temperature controls, lights, and so forth. So they're not interoperable at all. Now, as we said, ZigBee is used in industrial control systems, so you'll see this in a lot of infrastructure areas like power, lighting, sewage controls, things of that nature, water treatment plants, wherever there's industrial types of controls going on. And what you might have is communication that happens between sensors like power metering, smart meters and so forth, those kinds of sensors, and a central node. And this central node is called a coordinator. Again, all of this is ad hoc. It's a very small ad hoc network, but they all talk to each other. Now, you can also, as I said, use some of this in home automation schemes like light switches and alarm timers, but we really see this more or less in industrial control. There are some consumer devices that use ZigBee, as we mentioned. The coordinator controls the entire network, and that's actually where a lot of signaling takes place. Because a lot of these devices are low power, they tend to go to sleep, at least the end nodes do. And when they're needed, they wake up when a signal is sent to them or when a signal needs to be sent from them to the coordinator. Now, as I said, these devices are normally low power. They're always on devices, but they do go to sleep. You can run these from standard AA or AAA batteries, for example, or the standard 2032 types of batteries that you see in computers and other small devices. Now, we do have security in ZigBee, and this actually includes device authentication through shared keys. Now, the shared keys can get there any number of ways. If you buy a ZigBee network, these keys can be preloaded at the manufacturer and mailed out with the devices. But there are also ways to program these devices as well. Now, the data that is sent across ZigBee uses actually the Advanced Encryption Standard, AES, and the CCM method that you'll still find in things like WPA2. That kind of encryption is the same as in WPA2 networks. Now, obviously, ZigBee does have some vulnerabilities because it's a typical wireless network as well. Maybe not some of the same vulnerabilities, but a lot of them are typical. Things like interception of data could happen, interference, and so forth. And really, it always gets down to the encryption and authentication mechanisms used in a wireless network that causes the vulnerabilities. Things like weak keys obviously can be a problem, but you also can have keys intercepted. If the keys are not implemented correctly, then you could have a vulnerability there. Some ZigBee implementations, in fact, have a weakness in their encryption negotiation process, where the key briefly is sent out in plain text. So you have to watch for that, and it depends on the devices and the type of ZigBee you're using as to whether that vulnerability is present or not. Another weakness with ZigBee is that management traffic is typically not encrypted. And you might not think that's a big deal. If the data is encrypted, then who cares about the management traffic? But using that management traffic that's unencrypted, you could intercept that traffic and cause things like denial of service or spoofing attacks or rerouting data or turning devices off using only unencrypted management traffic. So there's a weakness there as well. Now again, ZigBee's not one of those things that you're probably going to get involved with a lot if you're doing 802.11 wireless networks. But it's a good area to get into if you want to get into the industrial control system type of work. So there's a lot of fertile field out there for ZigBee if you want to get into those things.